Hello, this is Mrs. Martin, and this is Notes on Logarithms Day 2. Here we go, we're going to recap. This is read, log base 3 of the fraction 1/81 equals -4. I want to recap and talk about that this right here is the exponent. This right here is called the value of the log, and this right here is called the base. All right, we're going to do two types of problems today. We're going to evaluate logs, and then we're going to find the value of x. Great. These evaluations, I call these special logarithms because they might be harder or something you need to know for memory of an exponent. So here we go. All right, number one, log base 6 of 1. Well, when you evaluate a log, you're finding the exponent. Remember, a log represents an exponent. So here we go. The base is 6. We're finding the exponent, and we want the value to be 1. Today, instead of using a question mark, I'm going to replace that with an x. Just another way of showing it. All right. What power of 6 is 1? Well, this is something we want you to know. Anything to the 0 power is equal to 1, so my evaluation here is 0. Number 2, we're going to evaluate this, so we're finding the exponent. The base is 4, the exponent is x, and the value is -16. What exponent will give you a negative number? I want you to know that there is no exponent that will ever generate a negative number. So, this is undefined. The reason this is undefined, if we were to look at the graph of 4 to the x power, this graph has a restriction, and there's an asymptote at the x-axis, so you can never get a negative value. That's why this is undefined. That is the reasoning behind it. Number 3, again, we're evaluating, so we're finding the exponent. The base is 7. 7 to what power is 7 to the 6th? This one, the bases are equal, therefore the exponents are equal. So if we're trying to find the exponent that makes this log true, x equals 6. So the answer is 6. All right, number 4. Number 4, we're finding the exponent. So 9 to what power is 3? Okay, this one, a little harder. Some of you might realize this. The square root of 9 is equal to 3. The square root of 9 can be written as 9 to the 1/2 power. So 1/2 power is a way of showing a square root. And 9 to the 1/2 is 3. So the evaluation of this is 1/2. Some of you may see that. I want to show you a more concrete way of doing this. We can take this 9 to the x power equals 3, and we can rewrite this 9. This 9 can be written as an exponent with base 3. So 9 can be rewritten as 3 squared. Well, 3 squared is another way of writing that. The x is there, so I'm going to hook the x on here. When you raise the power to a power, you multiply. Then over here I have 3. Well, this problem is very similar to number 3. When the bases are the same, then the exponents are equal. This exponent here is 1. So how I can solve this is I can set the two exponents equal to one another, and I can solve. I can divide by 2, and x equals 1/2. So number 4, the evaluation is 1/2. All right, let's go on to number 5. Number 5, we're going to find the value of x. These are equations. Notice these are equations where 1 through 4 are expressions. With 5 through 8, what we're going to do though is we're going to write these as exponents. So here we go. Number 5, I don't see a base here. Well, remember, this is called the common log. So the base is 10, the exponent's x, and the value is 1/100th. Again, this is a little harder, but if you want to make a fraction, that means this is a negative exponent. 10 squared is 100, so to get 1/100th, we need -2. All right, number 6. Number 6, the base is 2, the exponent is 8, and that equals x. All right, 2 to the 8th power. It's a little bit large, but we can find it out on the calculator. Punch it in. When you punch it in, you get 256. Number 7, we're going to find the value of x. Again, how we're going to do it is we're going to change this to an exponent. So the base is x, the exponent is 3, and then the value is 27. Okay, on this problem, we have to solve for x. Some of you may know it. Some of you may just know that 3 to the third power is 27. All right, so the answer is going to be 3, but here's how I could show my work. I'm going to solve this. I'm going to get x by itself. The inverse operation is cube root. And then what we can do is take the cube root of x to the third, which is x, and then the cube root of 27. You can take the cube root of 27 on your calculator, or you should know it. The answer is 3. Last one, number 8. Number 8 is a tough one, so here we go. We're going to solve for x. So first thing I'm going to do is rewrite this as an exponent. And then I can think this out. Now I can say to myself, well, 8 to the first power is 8. 8 squared is 64. So this answer of x is between 1 and 2. And I could just mess with it and figure it out, but I'm going to show you a concrete way. This example is a lot like number 4. I am going to rewrite this using an exponent. So the number 8. The number 8, we can prime factor it to 4 times 2, and then 4 can be factored to 2 times 2, and then times 2. So do you agree 8 is 2 to the third? So I can rewrite this left side, 2 to the power of 3x. 32, I can do the same thing. I can prime factor it. 32 I can write as 8 times 4, and then we just found out that 8 can be written 2 times 2 times 2. 4 is 2 times 2. That's 5 2's, so I can write this 2 to the 5th. Okay, here's what I want you to know. When the bases are the same, I have 2 on both the bases. Therefore, the exponents are also equal. So when the bases are equal, the exponents are equal. So I have the right to write an equation, and then I solve this equation. How do I solve this equation? I divide by 3. And then my answer to this is x equals 5/3. And I want you to know from the beginning, we said that this exponent is between 1 and 2. Well, 5/3 is between 1 and 2. All right, there's the notes, day 2.